Let's get going. Well, good afternoon, everybody, and welcome along to Data Platform Down Under for the month of June. Once again, this session is being recorded and will be made available on the YouTube channel once the session has been finished. A big thank you to our presenter today, Uwe Ricken, who's joining us from Germany. So it is quite early for Uwe, who will be talking to us about simplifying data management with partitioning. This is a very demo-heavy session, and I will be handing over to Uwe right now so that he can take us through today's session on how you can simplify your data management with partitioning. Thanks, Uwe.
Okay. Yeah, well, I'd say, first of all, from Germany, a good morning from Germany. I know that you're 10 hours ahead of us, so I think you will now go to, or not now, but when you go to bed, we start working here. And yeah, I'm talking today about partitioning, but not so much from the developer side, or let's say, give it a 50-50. Part is for the developers, and another one is for the DBAs. And I start sharing my screen. Come on. So now, yeah. Okay, so now I think you must see my screen, and I go to my presentation, and then we can go. Okay, now then we can start now. So as Warwick has told you or has said before in the introduction, this is a very, very heavy demo-based session. And yeah, what I want to talk about is a feature what unfortunately I saw in my career not very often implemented. So it's about partitioning, and we want to optimize our data workloads, or if you're a DBA, and I hope most of you are, I want to make your life a little bit more comfortable if you're dealing with big databases. So if you want to replay all the demos I'm doing, yes, in total there are 4 demos, but due to the lack of time, I just only showed 2 of them. I have a big database, the ERP demo database. You can download it from here. You have to have SQL Server 2012 or newer. And the smaller one, which is for the topics from the developer's perspective, that the customer orders database, and you will find the slide decks and the demos with the last link. A few words about me. Forget about the commercial thing here on the left side. I think the most important here is my email address. And if you have any questions concerning engine related, that's so important to say every single time, engine related, feel free to drop me an email, and I'm quite happy to answer it. And I promise I will answer really every question you send by email, SQL Server related. So a very important side note, the demos I'm showing here, these are use cases I have seen in real world. So all the demos I'm doing here, these demos are coming from real world examples I had with customers. So these customer scenarios, they are very much simplified for this session. Otherwise, it would take the preparation an hour or so on. So think about this: when you see the demos, everything comes from real world problems. And here is our first use case for partitioning. So I'm not talking about the basics of partitioning. I would expect that everybody knows the core concepts of partitioning. And the first one, this is for the developers. So a high transactional production environment, what we have optimized for this customer. And this customer is a pharmaceutical company here in Germany. And one of the biggest problems with these kind of customers is, and that's not only for a pharmaceutical company, automotive has exactly the same issues, is that they have various product lines. In my example, we have 16 different product lines. And the key point is that every charge must go through a quality check. That data from the quality check need to be stored in a SQL Server database. So when you think about automotive, they have exactly the same problem. when you see the assembly street in a big assembly company, for example, VW, this assembly street is 2 kilometers long, so 2,000 meters. And there are skids, it's called skids, where all the cars are putting on, and then they get assembled. They drive from station to station, and on the dashboard in the controlling area, they need to know where, at what point exactly is what car with its identification number in the assembly stations. So that is exactly the same thing. So here with this pharmaceutical company, I will replay it with 16 product lines, and this is looking like this. So now we have 16 machines here in our in the facilities, and what they are doing is, so the drugs get produced, and then they are scanned, and then the information where the data we're sending to a web service. This web service can handle all machines. So what happened then is that the web server will push the data into a SQL Server database. The problem this customer has or had was that the queue on the web service was growing and was getting fuller and fuller and fuller. And so at approximately 2 or 3 hours, the web server could not handle all this massive amount of data and pushing that into SQL Server. And then they called us, and we were investigating the system, and we very quickly found out that the problem is not coming from the machines or from the web service. There was a big web server here, but it was coming from the design of the database. So this database on the SQL Server was really fast, but it wasn't a problem of the hardware, but it was a problem of the design of the database. So here you see what problems we had. Every single production machine is storing in the same table. So we did not have any separate tables for the protocols for every machine, but everything was stored in one single table. So you see that we have a machine ID, then the sequence, but that is not so important, and we have a timestamp, the column D1. And when the vendor installed the system, they had only a database with one single database file. So what happened now? The massive amount of data were leading to so-called ledge contention, because the problem is that for 16 machines, and they had lots more, for 16 machines, the data were coming simultaneously into the database. The clustered key on the table was on the machine ID and on the timestamp. So what we saw then was that the indexes were severely fragmented because the machine IDs were every single time when we inserted data into the table completely different. So that led to page splits, and these are very expensive operations in SQL Server. And yeah, the question was, what can we do? You see here that one of the problems, and this is what you will see very, very often, is this is a problem you cannot solve with hardware only. Because you can have the fastest disk, you can have the fastest CPUs, it might help a little bit, but as more machines will come into this scenario, you will come back to the same problem, ledge contention. A ledge contention does mean here that SQL Server, before it writes data into the table, or even if we select data, it has to have a short system-based lock on the data structure, on the page structure, before it is performing the action. And this is something where absolutely no hardware can solve this for you. So you need to have a redesign of the solution. The good thing here is that partitioning in SQL Server is a completely transparent solution. So that means whether we are working with partitioning or not, it is transparent to the application. So no hardware or no software changes are required. And that gave us the opportunity to implement it this way. So how did it work? What we did was, and I show it in the demo right on, what we did here was we were separating our big table into different partitions. So every single machine now will get its own partition. And you see this here in the slide that machine 1 has one partition, machine 2 has one partition, and so on. Another very cool feature when you're using partitioning is that you now can perfectly, I really say perfectly scale your workloads. For example, in this pharmaceutical industries, the 16 machines, they have different payloads. So let's say the first one is producing pills for headache. The next one is doing something for heart, so is producing drugs for problems with hearts and so on. And the quality management for every single product is completely different. So we have, on the one hand, more information, and on the other hand, less information. And what you can do if you're dealing with partitioning is that, for example, the machine with the higher workload, you can scale it by adding more files to this partition when you're using different file groups. And that's what we did. So our table was separated from the virtual part of it into different file groups, and every single file group could hold one or more data files for scaling up the writing performance. So let me show you what the improvements were. By the way, feel free to ask a question whenever you have a question here concerning this demos. So first of all, let's have a look to the infrastructure, what I did so far. In the management, you will see here that I have implemented 2 extended events here. This one is for the first demo, for the high transactional demo. And let me show you what I'm recording here. So in the events, I will have page splits, and I come later on to good or bad page splits, and some information about when a ledge has been suspended and what we are waiting for. So now we can start with this. I go with the first demo. The first thing what I'm doing is I'm creating my basic infrastructure, and therefore I create a demo database. And here is a very simplified structure of the so-called telegram table. I have a machine ID, and I have a date time column or timestamp column, and then this is my payload. And this is a default that I always enter, or that I have a fixed length of 1 kilobyte for producing a little bit more write activity. And this was the first design error from my point of view. You see here that I'm now creating a unique clustered index, which is on the machine ID and then on the column, on the timestamp column. We'll very quickly see that this could lead to problems. Here is my wrapper stored procedure, very simple, very easy. And what I'm doing is I'm calling this stored procedure with a dedicated machine ID. And the only thing what the system is doing, it's pushing data into the table. So what I now do is, you see here that I have an X event, as I said, for the transactional process. I clear my performance counters. And now see how we can put some pressure on the system. Therefore, what I did, and I want to get a little bit into detail into this, I have created a workload file, very simple, very easy. And what I'm doing is I'm running simultaneously 16 processes here. So for every single machine 1, I'm running OStress, which is part of the RML utilities, connect to my server. And then I'm executing this store procedure for a dedicated machine. For every single machine, or for every single process, I execute this store procedure 10,000 times on this demo database. So let's do this. And then we go. So, so now the system is running. I'm now creating the 16 processes. In the meantime, let's see what we are waiting for. And you can see here, we have the write lock activity, which is the number 1. This is absolutely okay, absolutely as expected. Write lock does mean that we are producing or that we are writing data into the database. You can see that the write lock wait stat is dominating our system, and this is what we expect. But as a side note, we see this one here, the page ledges. The page ledge exclusive does mean that when SQL Server will write data into a table, it has to protect the data page. So in that moment, when we have the protection, have the lock implemented, first the protection of the page, then the lock, and then we can write this. You see that it's not waiting very long, but this is due to the fact that I have a very small workload here, only 16 machines, but I have a machine with 8 cores and with a flash drive in my computer here. So that is the reason. But with the customer, that looked completely different. So the write lock was fine with the 85 to 90%, but they had nearby 5% of page ledges. So contention on the table. So I think now it must be finished. Let's see. Okay, it is running. Let's wait a little bit. And we can go now, see what, come on. Oh yeah, here we are. So now these are the results. And what you can see here is that every single process was around, and this is very slow, by the way, 1 minute and 40 seconds here for executing 10,000 insert statement. That is really, really long. And that is here the average. And you see that it is nearby the same time for all of the processes. So now let's, come on. Okay, we go next step. So one big problem. Next problem is have a look to the indexes or to the index itself. And what you see here is exactly the problem this customer had. We have a fragmentation of 99%, and we have our 160,000 rows inserted. That's fine, over 22,871 pages. But what was taking so much time here? This is the question. So, and the reason for this is you have seen the ledgers, the page ledgers, but there is another issue, and this is something what we had not seen before, or the developers had not seen before. You remember, I have here my X event, and what I'm doing now is I'm pushing my information from the X event into a temporary table, and now I run a query against the data, and what I want to see is how many so-called page splits we have. What does a page split mean? Well, think about this when we are talking about page splits. When we insert data into a index table, SQL Server will always make sure that the record will go logically exactly to the point where the index key must reside, because an index does always mean that we have data ordered by the index key. What will happen if a data page is completely full? Let's say you have 5 records in one page, A, B, C, F, G, H. And now you insert a new row with a D. Then SQL Server must make sure that this row is between C and F. But when the page is full, what happened then? Well, what SQL Server is doing, it's taking around about 50% of the data from this page, bring them to the very end of the index, and then we have 50% free, and then we can insert our row. What we then have is so-called bad or good page splits. A bad page split does mean, or first of all, let's see what is a good page split. A good page split does mean when one page is full, we immediately create the next page, the next data page directly at the really next page. So that means that we do not have any gaps in between the pages. A bad page split does mean that we have that we insert a row into an index, but therefore the half of the data must be transferred to the end of the index. We link it again, back again, but 50% needs to be moved, and then we have a gap in the order of the pages. And SQL Server need to jump to the page to read the data. And these so-called bad page splits are here in the result. And have a look to this one here. We have 21,068 so-called bad page splits. And this is something what consumes time, but not only time, but it consumes transaction log activities. And now we think a little bit bigger here. What about if your database is member of an availability group or mirroring or something like this? Then it does mean that these transactions need to be transferred to the secondary the same way, and that consumes more time. And this was one of the points, one of the reasons why the queue was growing and growing and growing. So what can we do for this? This was definitely way too slow. After 3-4 hours, the queue was full and they needed to restart the system. So I truncate my table. And what I'm doing now here, I do it in a cursor. I create now for every single machine from 1 to 16 a new file group, so that every machine has its own file group. And for every single file group, I add one single file with 128 megabytes. That is the first part. This is something has nothing to do so far with partitioning, but this is the physical infrastructure, what is required for the solution. Let's have a look to the demo database, properties. And here are my files. You see, machine number 1 up to machine number 16, and every single machine has its own file group here. As I said before, the reason for different file groups is now that when I see, for example, that machine number 7 has a higher payload than machine number 1 or 2, then I add one more file to this file group to spread the writing workload over multiple files. You know this technique, for example, from TempDB or from data warehouses. So this was the first part, that is the physical implementation of partitioning. And now we come to the point where we implement the logical part of the partitioning. The first thing what you need for partitioning is a so-called partition function. A partition function determines the boundaries for the values you want to insert into the table. You can see here that I have boundary for machine number 1, number 2, up to number 16. So I create this partition function, done. And this is very, very easy. For example, if a new machine should push data into the database, no problem. Then I modify the function for the next machine, add a new file group, add a new file, and that's it. So now SQL Server know when we use this function later on, for what machine we have a separate dedicated partition. So now the last step for implementing partitioning is that we have to create a partition schema. And the partition schema combines the function with the physical implementation of the different file groups and files. So think about this as the glue to put all together. So you see here, I create this partition schema based on the partition function, 1, 2, 3, and so on. And the only thing what I want to mention here is when you are dealing with partition scheme, think about this. The partition schema must always have one more partition than the function actually combined. See that I have 16 machines, machine number 1, and think about this. The first value go into this. The second value go into this, and so on, and so on, and so on. The number 16 go into this. And then you see here that I have another file group as part of the partition schema. And the reason is very simple. SQL Server must definitely make sure that when we have values which are out of this range, that these values can be stored in the table. The range left, what you see here, this mean, this is the so-called boundary, and in short words, it does mean everything what is smaller or equal to 1 goes into this partition, or into this file group, sorry. Everything what is smaller or equal to this go into this file group. But what about if someone inserts accidentally the number 17 or 18 or 19? Well, no problem. It goes automatically to this partition here, to this file group here. So I implement this. Done. And now our infrastructure is ready. So this is the implementation of partitioning. And what you can do now is you can now use these partitioning construct for every table in your database, whether it makes sense or not. Yeah? Here, what I'm doing is I'm using it for the machine protocol. I drop the index. What I then do is, and that is, by the way, it's very, very simple. You see that I create again the unique clustered index. On the machine protocol, these are my index keys, the machine ID and my timestamp. And the only difference between the implementation of an index before and now is that now I say SQL Server, please use the partition schema based on the machine ID for storing the data. This is it. Let's have a look to this. And here is my table. And you see that my index now is distributed, or we do not have data here. But now you see that we have our 16 partitions, no data in, no rows, because it's empty. And we reset the weights. And then I restart my X event. So 1 minute and 40. Let's see how long it will take now. So we start again 16 processes. While it is running, we have a look to the weight stats and look to this. We do not have any latch contentions here. And if we try only write log, nothing else, only writing, no more contention on the table, and we have to wait a little bit here. I'm really wondering that it takes so long, by the way. Normally it is finished in 20 seconds, but maybe it's because it's early in the morning and my computer decides, hey, come on, my normal working time is starting from 6 o'clock. So see this. Instead of 1 minute and 40, we have here 36 seconds. This is a huge gap, but this is normally not so high. This is from the God of Demo. Here, normally we have an improvement of 10 to 15% only. Here it is more than the half of it. So that's not really, that's not a real value here. But think about this. From 1 minute 40, we were going down to 36 seconds, and normally expect only 15%, 10 to 15%. But why are we now so slow? so fast. First of all, you see here that we just only have write log weights, nothing else, absolutely nothing else. And where does it come from? Well, one of the big points is we do not have any more index fragmentation. And this is absolutely clear because why? Look to the definition of the index. We create the unique clustered index first on the machine ID. So every single machine will now push its own data into its own imaginary table. So every machine has now its own partition. Think about this as a table. And then we have the ascending value of the timestamp. So D1 and so on, and going on and on and on. And when you look for the number of page splits, that's all. 7 bad page splits only, instead of 21,000. So our transaction log will is definitely one guarantee here that we write way faster than we did before, because now we don't have this massive overhead of these bad page splits, which is by default around about 16 kilobytes per each, producing data in the transaction log. Now we just only have 7 or 8. The maximum I had was 10 so-called bad page splits. And they, to be honest, they're coming from the B-tree structure, from the intermediate, not from the data pages itself. So this is a really massive improvement we have with this customer. And after we have implemented, the queue have never been, since now, never been filled up again, that they had to stop the processes. So now we clean the kitchen and go for this. Do you have any questions about this scenario? Right. Cool. I hope that you see that this partitioning does nothing, absolutely nothing has to do with improvement of queries or something like this. By the way, partitioning, I hear it very often when I do workshops with developers, and quite often I hear, well, yeah, I'm using partitioning for better performance of queries. To be honest, this is not the case. There are really minor cases where partitioning can help you to eliminate in a query partitions, but basically partitioning, or the core concept of partitioning, is improvement in DDL commands, in workload commands, data warehouses. So the next two I will skip here because I want to go now to the management of big databases. You need to know a little bit about my career. Before I was becoming a SQL master, I was starting with SQL Server as a DBA back in 2008 in Deutsche Bank here in Germany. And I would say, yeah, the leading database engine in a bank is Oracle, and it is always. So, but what we were, as a DBA, we were a team of 4 people. And I did not have very much experiences with big databases, while the Oracle guys had, because they were always dealing with big databases. So then it came to us that we had a database with around, let's say, 2 or 3 terabytes of data. And one day we ran into a problem, which was, for me, as I would say, unexperienced DBA, a pure nightmare. The database was crashing and we needed to restore it. And restoring a database in a bank can be a big problem if you're not doing native backups. So if you have third-party backups, then it could be a big problem because you have to wait for the tapes, you have to wait for a slot, and so on and so on. However, the restore was taking over 7 hours. And think about this, you're sitting there and permanently emails are coming in. How long does it take? Like little kids, you know, when you go to a fun park and you're starting at home, it takes only 5 minutes, and then the kid's starting, hey, Daddy, how long does it take? You're 2 hours. And after 5 minutes again, Daddy, how long does it take? And that was exactly the same situation. So we were not really experienced with doing this kind of stuff, and we are not experienced with dealing big databases. Nowadays, it would just cost me a smile and having fun, see the management getting nervous, and you know that you can fix these problems in a very fashion way. Here comes the point. A large company's administrator must recreate indexes, statistics, do a restore of the database, and so on from a 4 terabyte database every night. Furthermore, the SLA determines a downtime for hot data within 60 minutes. So 4 terabyte is, 3 years ago. In the meantime, now we have 6, 7, 8 terabytes of data here. And one of the problems here was that the very, very small service time did not fit to do all these jobs in a fashion way. So what could we do here? And you will see that partitioning will improve your work as a DBA in a tremendous way. So SLAs for DBAs are the 2 points. The first one is the RPO and the RTO, recovery point objectives. And that does mean how much data you need to restore when it comes to a crash. And the recovery time objectives, what does mean that how long does it take to restore the database? So when you're dealing with big databases, there are a few considerations. Is it required to back up the complete database every night? I see it, I would say 90% of all my customers who are doing that. You know what? When they see that the databases are growing, they do not think about their backup strategy. No, they buy faster disks. If the backups can fit into this fashion time. How long does the backup take? How much storage does it consume? Maybe differential backups will help. That means that we just only do once a month a full backup, and then every single night we do a differential backup, or when we see that the differential will have the same size as the full backup, then we again start a full backup and we go again with the differential backup afterwards. So then if you have these information, think about the nature of data, what you have normally in big databases. Big databases have 2 separate, let's say, kind of data. The first one is the hot, so that the actual data, and we have the cold or old data. And I do not know how it is down under, but here in Germany, we love to collect data. So I sometimes have the feeling we are in Germany, we love to collect data. So when we separate between hot and data and cold data, why not putting old data in read-only file groups? The good thing with this is they will never ever change again, but only the hot data, they get permanently changed. And for example, see this, in a company, the requirements was the last 2 years need to be writable. Excuse me. The other days before, and other years before, and they had 18 years, we do not change it anymore, and we don't need it anymore. But need does not mean delete them, but say sometimes we want to have a look to this. So what we were thinking about was, well, then in this case, why not use partitioning for the read-write file groups? It's the same question with the restore. Can a full restore of the database cover the SLA? Basically, what I've seen so far, the answer is very strict, no. Definitely No. If you have a 10 or 15 terabyte database, size database, it cannot be restored in 30 minutes or in 90 minutes. It takes the time. But what you can do then is, why not restoring only the read-write component of your database, and afterwards, when the business is working, then you restore your read-only file groups. So here comes the demo for this. I have a customer orders table, and for every single year, I create a partition, and the data goes from every year into its dedicated database files. So what we then do, and this is only once a year, all data which are older than 2 years, you see this here with the red database files, they get marked as read-only. So we can never touch it again. Or we can touch it, but we will never change it again. And only the last 2 years, 2019 and 2020, these are the, let's say, the active part of the database or of the table, and they can be changed. So, oh, sorry, too late. Let's play around with this. And therefore, first we close this. Okay. Clear the, oh my goodness, this annoying noise in the background with this ping, ping. Greg knows about what I'm talking about. We have a discussion about this. So, yeah, come to the file group restore. So once again, I create my database, my demo database, and then I'm pushing 3 million rows into a table. So that's it. So this is the starting point here. My database is not partitioned, so we have all our data, 3 million rows here, and this customer had 300 billion rows in this table, is now in my database, and the restore normally will take, now let's say, 2, 3, 4 hours. So then what we did was the following. In the first step, I create my partition function again. This is the date. So we're starting with 2000, going up to 2019. This is my partition function. And the next step, and this is something what is really mandatory, when you're dealing with partitioning, I see developers are doing it very, very easy. They create an index then based on this partition schema, on the partition schema, and put everything on the primary file group. To be honest, this will not help to cover your SLA. The primary file group must always be restored at first. So when the primary file group is not available, then the database is not functional. So I create here my partition function, then I create for every single year my dedicated file group and my database file for it. And here I create my partition schema. That's it. Infrastructure is up and running, and we can start now. So the next step that took a little time, because we needed to recreate the clustered index on it. And there was one little drawback here. You see here that I have a unique index. The unique clustered index basically was going only on the ID. But if you want to create unique indexes on schemas, you have to have the partition key as part of the index. So that means that not the ID is the one which is unique, but always the combination from ID and the order date. So now I move my table to the partition. That's it. Let's see how it looks like. So you see here, this is the, here we have 11 megabytes stored, 62,000 rows, 62,000 rows. And here, since 2017, my business was growing up. So we got 500,000 orders and so on and so on. Now let's see what the next step is. So my database is now up and running. It's functional. The business is working with this. And this is only the half of the work to do, because now what we have here is our database, by the way, it's running in a simple recovery model. That's only a side note, is now functional. But when you restore later on the database, you will run into exactly the same problem. What we have to do is we must now modify the file groups which are dedicated to read only. So what I'm doing is I'm taking every single partition here up to 2018 and say, okay, everything what is smaller than 2018, make it read only. So I'll run this one. Preparation is done. So now I have several file groups which are read only, and only 2 of them are accessible for read and write. So here's my 2000 years read only, and so on and so on. And look to this. The year 2018 and 2019, they are functional for writing data. And now I do a backup of my database. And now think about a situation a DBA will never, ever have a lifetime. It is 6 o'clock in the morning. Someone is calling you from the business and say, oh my goodness, our database is gone. And you are now in an extremely stressy situation. Trust me, also, I would say I'm quite experienced with these kind of stuff. I really always get really nervous when I know that a crash had occurred and the business is standing behind me and say, how long does it take? What is the situation? Blah, blah, blah. Nowadays, I would say, shut up, go take your coffee. Let me have my time here. I'm doing the restore. But 10 years ago, I was absolutely nervous. Now we take it very, very cool. Let's check how long does it take to restore the full database. So the situation as it was before partitioning. What does this mean? When we do not have partitioning, we are required to restore the full database completely. So here we go. And now it's done. Okay, yeah, it's a fast one, but have a look. It took 1.4 milliseconds. This is only a few megabytes. What will it take now if it is not a 300 megabyte, but a 30 terabyte database? Now the situation is the following. You come in, it's morning, 6 o'clock. The business is running to you, say, oh, our database is down. Help us, pray to God, help us. The first thing you do now is go to the kitchen, grab a coffee. And now you go to your desk, and the only thing what you need to do is we are running this statement. What I say to the system here is restore database, but the read-write file groups only. So these are our hot data. And I say, well, restore them partial and with recovery. With recovery, by the way, if you want to do this, you need to have Enterprise Edition. So now I restore my data. Here it is. And now my database is working. You see here that I have only the orders 2018 and 2019. Now turn around to your customer and just tell them, boys, you can work now. Go ahead and run your business. And let's see how this looks like. You see here that now from my database, this is the primary file group. This is my transaction log, which is online. And when I scroll down, these here with recovery pending does mean, well, sorry, actually, I do not have the data, but look to this. Hey, yay, they're online. We can work with this. Let's check it out. First thing, I want to run a query against the customer's orders for the January 2019. 2019 is read-write and works. So the business can work. But another requirement for the business is, hey, can I write data? Before we come to this, have a look to this query here. And so normally I would, if that would be an in-person event, I would ask you, will this query work? Here it is a little bit difficult, but the answer is no. This query, these kind of queries cannot work. The reason is, think about the partition key. The partition key is on the order date. So that means that for every single year, we have a dedicated partition. And if we run a query for a non-partitioned attribute, this will fail because SQL Server now has to go through every single partition starting on 2000 and going to 2019. But this is something which cannot work because only 2 file groups are available now. And you see, say, sorry, the one of the partitions for this index is not online. Okay, no problem. But this is clear that this cannot work. But this one here, this will work. Because now I say update my customer orders with the ID, and you see here that I now have my partition key part of the where clause. So it's a predicate which eliminates other partitions. So SQL Server now definitely know that it only has to touch the partition where the 2019 data are in. I run this and it works. So what we can say so far is that we have a functional database for the brand hot data for the application. Think about this, maybe it's a high transactional system for banking, and they need only to push data into it coming from high transactional processings. Then you can say, perfect, it will work. Just only restore your hot data and the business can work again. Now, when the business is gone and they are so happy that they can work, you now start the restore of the rest of the database. So what I'm doing now is I'm going through all the other data here, beginning from 2000 up to 2017, and I say, well, restore only this file group coming from this full backup. I hope you will understand that at this time here, when we run this, the restore will take longer because now we need to access 17 times our full backup, and we execute this. Then we come to the first, second, and you see every single time when we restore, it gets again access to the full backup, and it takes time. But this is okay. For us, from the perspective of an DBA, it is absolutely fantastic here because we have now the time to do that. We don't care about the time, what it takes. The only thing, and maybe that makes the business a little bit annoying, is that every single time you restore one file group, you send an email out to the whole company. Yay, I've restored partition 2017 and 16 and so on. Maybe not everybody in this company will be happy about this. So here is the result of it. Now everything is online. Another really cool thing when you're working with partitioning is index rebuild. I think and when I look into forums asking, oh, I have a big table which is hundreds of gigs in size, and I cannot do an index rebuild on it because the index rebuild takes so much time that it will slow down my system. So what can we do? Partitioning will help you here in a very easy way. Let's go quick through this. So what I'm doing, I again create my demo database. I push in the data, 3 million rows. Then I create my partition function, add a file group and the files for each partition. And then I create my partition schema and I create my clustered index on it. Okay, so this is my actual situation. I see here my dedicated partition, number of pages, everything is absolutely fine. So now 2019 is over and 2020 is starting right now. So what we then now have to do is that we create for 2020 a new partition. And that is so easy to do, really easy to do. First step, we add a new file group. This file group is for 2020. Next step, we add a database file to this file group to store the data from 2020 in it. Then we alter our partition schema. We say, hey guys, the next partition you should use is when it comes to a range split in the function is the partition P2020. Otherwise, it will use the primary. And the last step is to modify the function and say, hey, we have new data. That's it. We want to store new data in a new partition. So now we go, let's have a look to this, execute, and this is my situation. Here is my year 2020, no data in, everything fine. Now think about this. Let's say this table has a size of 600-700 gigabytes. And an index rebuild, this is a massive impact on your system, whether it is an enterprise edition or it is a standard edition, it's a massive impact. The reason is very simple. An index rebuild forces SQL Server to write the complete table new. So that means a 600 gigabyte table goes into a new area of the database file and gets rewritten. So 600 gigabytes writing in the database file, writing transaction log. So if it is an enterprise edition and you have an index rebuild online, and this has a massive impact on the log file because it is not a, this is not a minimal locked operation anymore. So here we go and put new data in our customer orders. You see here, it's very simple. I only add the 2019 data from January as 2020. Go for this. Inserted. 42,000 rows affected. And let's see how our partition looks like. So here is my 21. Some of the fragmentation is very small. That is okay. That is expected. We have 99% usage. But now let's see what it takes when we rebuild the index. And here, I cannot, in this demo, I cannot really show the time difference, but I want to show you a big problem with rebuild with lockings. So here is my statistics. I want to see how much time it consumes, and I put the alter index in a transaction. The reason is that I want to show you what locks SQL Server will have here when we do an index rebuild. Here is the rebuild that has been done. And now look to the lockings. And this is a very interesting thing. So these are system objects. Forget about they are not so important, but this one here. You see the hobbit. This is heap or B tree, and every single row you see here is a partition. It is a partition where we have a schema modification lock on it, very restrictive. So it does mean that now nobody can access the table. We are here, we are locking this, and the schema modification is held on the object itself. So in simple words, my whole table is locked now because I didn't do this online. And now we put a little stress on the system. I now push for 6 month data into the table. This is a normal working process. And now we look to this. Here is my fragmentation again. You see this here. This is 21. And we have 97% fragmentation. And what can you now do as a DBA? When we think about the index rebuild, the biggest problem is that we lock the whole table, and you can avoid this. And with this, you have two benefits. First is when we just only rebuild the actual partition, then we make sure that we only affect the data which has really changed. The rest didn't change anything. So when we rebuild only this partition, then we save lots of time here because we only do the change on the last partition. And the second thing is that we do not have a massive transaction lock, what we produce here. See how this will work. You can see it here. In the first step, I want to know what is the partition where the actual data are in. You see, I'm asking for the data from 2020. Then, when I know this partition, let me run this one here. You see, this is partition number 21. And when you run an alter index for a rebuild, you have the option to name the partition you want to rebuild. And that's it. I run this one here and see how fast it was, how incredible fast it was. By the way, only this partition get locked. Fantastic. Now we do not block the whole table, but only this affected partition. And the second thing is, and that makes it so interesting for us to run index rebuilds on partition tables, is that we save lots of time here. Now it is, okay, this is 21. And you see here that now it's okay that we have, did I run this? Yes, 1 second. So yes, and okay, maybe too less data here. But the fragmentation is 0.1, so it's only, even it's not 1%. That's what I want to have if I'm a DBA, and if I am dealing with big databases, then I have the chance with the rebuild or partitioned to save lots of time. So what I see very often is as bigger the databases, as shorter is your service time over the night. Last demo is statistics update. Exactly the same thing. So I one moment, need to close this one, go for this, and here comes the last demo. I again create my partition, I create my my data, and then I create my indexes. Here we are. And that's it. So these are my partitions, my dedicated rows in it, and see my statistics. Excuse me. So these are my indexes here. My statistics, and I run an update. If you want to, this is important. If you want to make update on statistics on partitions, and you must have statistics which allow incremental scans. I run this. Here we are, that is okay. And now let's go check the statistics for 2019. So we are expecting 1,400 data. Go to the execution plan and you see, yeah, nearby, that's perfect. So you know where the estimates are coming. I will skip this here. Let's go through this. So here we are. So in total, this is my object. And one moment, did I filter it? Yes. And you now see here that I have for every single partition a dedicated statistics object. And when you want, oh, where are the rest of it? Oh my goodness. There is something lost. Unfortunately, I need to check it. I didn't know this, but I think the last time I demonstrated it, there was I dropped code here. But now you have to trust me. What you can do is you can run an update statistics based on a dedicated partition only. So when you combine these three things, the index, or sorry, the file group restore on read-only file groups, the index rebuild on dedicated file groups or on dedicated partitions, and the statistics update on dedicated partitions, then you will have always, really always, enough time for your service window for these big databases. And this is the most important thing, you can sleep very calm every night because you know in case of an accident, when a database gets dropped, accidentally dropped, or it gets corrupted, your restore will only take a few minutes, maybe 1 hour, for example. It depends on the size of the database, but not the whole day. So as a resume for everything, developers, you can speed up your workloads when you're using partitions because you get rid of these expensive ledge contention, and it might be that the indexes get not severely fragmented. As a DBA, I could strongly recommend to you use partitioning for better maintenance windows, for improving your maintenance windows, for indexes, and for statistics. And as a perfect side effect, if you're using partitioning and you mark file groups as read-only, then you have the chance to restore the hot data in a very small amount of time instead of restoring the full database. That it was, and I hope you enjoyed the demos. I'm very sorry about the last one, but I promise I will add the rest of the code back again if you would like to download the demo files. So thank you very much for having me down under. And now, any questions?
Thank you, Uwe. Yes, we've got a couple of minutes left. Got a couple of questions from Mike. So first up, just thinking about the partitioning for hot versus cold data, is there a practical limit on the number of partitions you should have in your function and scheme? For example, if you're creating a new partition for each month, at what point would it be sensible to roll up the old data into a yearly partition or even a single historic partition? imagine having 300 partitions for 25 years of data, for example, would be a bit unmanageable.
Yes, that is a good question. And I nearby had the same question on Saturday when I did this in Croatia. And you know, the best answer ever, Mike, is it depends. No, just kidding. Yeah, this is the key point is that you can manage up to 15,000 partitions in a database. And to be honest, this is not really useful. So the cold data or the separation between hot and cold data depends really on the requirements of the business. If the business is telling you that it is, for example, wants to have hot data on a monthly base and say only the last 6 months must be available, and in conjunction with a really, really big database, now I'm talking about 30, 50, 40, 50 terabytes, then my partition strategy would be to put a full year as a sliding window, by the way, a sliding window, 12 months into a monthly partitioning. And at the end of the year, I would move them over. So that means I have 12 partitions for the month, 1, 2, 3, 4, 12, and so on. And then at the end of the year, I compress one full year into another partition, which is then based on the year and not on a month. What you can do then is you can compact them with column store indexes. There are two different kinds when you're using column store indexes, the operational and the historical one, which have a higher compression. But basically, it all depends on the requirements of the business. Monthly, I have one customer who it's a consulting company, and they are producing so-called management reports every 3 months, and they have partitioning on a quarterly basis. So every 3 months is one partition, and they're doing it for 2 years, and then they compress it to a partition for a full year. Is that answered?
Yep, that's great. Thank you.
Okay. Mike had a second question for you, Uwe, around backup strategy to file groups, so that when you restore each file group, you only have to read each file group backup file once, rather than the entire full database file several times.
Yeah, Mike is for this demo purposes, I did not do more backups. Yeah, so you saw that I was restoring only from one big full backup. But basically, what you're doing is when you're using partitioning as a DBA, I would normally restore, let's say once a year, the full database completely. But then the full backup would only concentrate on the read and write file groups only, but not the whole database. That does not really make sense. Yeah. So the full backup was only here for the demo. But normally what you can do, and this is a great feature, by the way, is run a backup only on the read-write file groups. That works pretty well. But you have to have, for a full restore, the read-only file groups in different backup. That question answered, Mike?
Yeah, that's great. Thanks. I guess an offshoot of that is when you're testing your backup files, which you should always do as your restore strategy, should you be testing your read-only file group backups as well, or should you just test the ones that are the read-write file groups, which are changing all the time?
Yeah, so testing a restore, a very good point. I don't see it very often, but yeah, if you just only have the read-write file groups, that's okay. In a bank, we were required to do restore tests once a year, not every time. I think it's a little bit risky, but checking the restores nowadays is that you can run if you do the backup You can when you use Ola Hallengreen scripts, for example, they will check it afterwards. But with a big database, you don't have the time to do that. So if you run the backup on the read-write file groups only and test it afterward, that will work the same way, and it will spend a lot of time.
Yeah, it's almost a no-brainer these days with DBA tools. You can just script it, and every time you do a backup, you can just script a restore on a test server. It's super simple.
Yes, yeah, we have it with one customer. We did it with one customer, but think about this: you need to license it. Yeah. And this is something what lots of customers, especially when it comes to smaller customers, they don't want to do.
Okay, that might be a little bit of a grey area with Microsoft and licensing, maybe.
Yeah. But they are resistant against recommendations. Sometimes it is, and then they have to learn it the hard way. So, there are a few questions, but Mike, everything is answered so far, yeah?
Yes, that's great. Thank you.
Okay, good. So there are coming 3 more questions. You use partitions with column store indexes or with in-memory tables? Answer is yes. Yes, absolutely. In data warehouses, we are using it heavily with column store. In memory, I didn't use so far. The reason is very simple. So if you think about the first demo with the pharmaceutical industries, that could be a good chance to use it with in memory, by the way. Yeah, but this all depends on the vendor side. So the vendor side must develop it as in-memory technology, because only creating an in-memory table does not mean that you now lock-free. Okay, you're lock-free, but it does not mean that you have the best benefits out of it. So you need to have compiled store procedures for this. So in-memory does always mean that you have to redesign your system. And if the vendor does not do this, then you only can do it from the architectural side, the way I did it with spreading the workload over multiple files. And another question is coming from Ashok. How would you migrate from single non-partition to partitioned database? There would be a total redesign of database and queries. Ashok, this is so you have seen the migration, but it's not partitioned database. It's more a partitioned table inside a database, by the way, just only to make sure that we are talking about the same. That is very, very easy. There would be a total redesign of the database and queries. This is only, yeah, Warwick? Any question, Warwick?
I am. I'm just finishing that one off to then join to be on with you guys. I'm not sure how, because in my calendar I've got the meeting starting at 2 o'clock. That's all, and obviously everybody else on the call had it at
Warwick? Okay, yeah, no, okay. So, there would be a redesign of the database. No, not really. Based on the architecture, this is completely transparent. But, and this is something, Ashok, you are right. When you're using partitioning, it might be that you have to rewrite queries. Because one of the biggest problems with partitioning is when you do not run, if you do not use the partition key in your queries, then SQL Server has to scan all partitions. So the benefit of partition elimination will not work here. What you can do then is, if you only want to have partitioning for infrastructure problems, then use so-called non-aligned indexes. So that means they do not have the partition key on it to speed up the queries. But yes, basically there is a, when it comes to queries, you need, or it is sometimes required to redesign queries. But if you do partitioning in a database, neglecting queries, then it is completely transparent and nothing need to be changed in the application. Yeah. Is that query then answered, Ashok?
Yep,
Okay.
you're right. The only my concern is if you have a vendor-based application,
yeah,
where the database and queries, everything is already pre-developed. In such a case, it will be not possible to migrate to the partition schema.
absolutely.
Yeah,
Yes.
only when you are designing a new system, it's worthwhile to take your approach.
Yes. Yeah, you are hitting a very important point. When you want to implement partitioning as a strategy to your database, you always have to talk to the vendor. And let me tell you why it is so important to include the vendor. What I see very often is that vendors are, when they implement updates in the database, they drop existing indexes and recreate them. And if you, for example, have implemented for a big table a partitioned clustered index on it, and the vendor will drop it and create it with a new one, which is not on the partition, then you will lose the performance or the benefits you had, and that means that you have to recreate the indexes again based on the partitions. So yes, absolutely, always talk to the vendor that they make always sure that you talk to the vendor, that you know what they if they support it. Unfortunately, what I see very often is if you ask vendors, hey, can I use partitioning? The core answer is no, we don't support it. And you know why? Because they don't understand partitioning. This is what I find very often here. Next question comes from Fernando, but by the way, thank you very much, Ashok. Can you use all functions with Dev Edition or just with Enterprise? I mean, for partitioning. Hey, Fernando, here comes the good thing. You can use it with Standard Edition when you're working with 2016 or newer. Before 2016, partitioning was a feature dedicated to Enterprise Edition only. Since 2016, it is for Standard Edition, and unfortunately it doesn't find the way to applications so far. However, yeah, it's good that Microsoft has opened it to Standard. Yeah, Greg, you are right. Yeah, what was never found in memory, OLTP is useful. That's true. It's a very dedicated use cases for a hackathon. Developer edition is feature parity the same as enterprise. Yeah, the only difference is licensing. Yeah, that is true. Mike, you are right. The developer edition is from the functionality, it is enterprise edition, but you can only use it for testing and for development, but not for production. Yeah. Okay. Any more questions? Well, then I would say, so here in Germany, it is 6 o'clock in the morning. It's time for another coffee. And I thank you all very much that you've attended my session from a guy coming from Europe. And I really hope, and that's what I asked Warwick, that we could meet in any in-person event over the next years in Australia, because I've never ever in my lifetime was in Australia and I really want to go to. Thank you all. Have a wonderful time and bye-bye.